Hello everyone, I'm Caroline, and today let's learn about the inverse operation problems and the prime number. Very happy to see you again. And today is the day off, right? Have a good day. And today is the day off, right? How about your holiday? Okay, let's see the inverse operation problems first. What number should be written in the first flower to get the number in the last flower? Okay, so in this question, you only need to reasoning from back to front. Okay, from back to front. Let me find my pen. Okay, so the last result is 12, and which number plus 11 is 12? Actually, when you want to calculate this number, you only need to use 12 minus 11, right? So you can do the step on this process. Yeah, just to give it an arrow here, minus 11. So in this flower, it should be 1, right? 1, and double check your answer. 1 plus 11 is 12. Yes, correct. And a number minus 5 is 1. So this number should be 1 plus 5. Okay, so 1 plus 5 is 6. Yeah, very easy. 6 minus 5 is 1. Correct. And the last one. A number divided by 2 is 6. So we just change the direction of this arrow, and then it should be times 2, right? Just to find its opposite symbol. So times, a number times 2, 6 times 2 is 12. Okay, and double check your answer. 12 divided by 2 is 6. Correct. Okay, then it means the whole process is you can work it successfully. So very easy, right? Okay, that's all. This is inverse operation problems. And next day, I will give you inverse operation problems about the word problems. Yeah, it's the word problems, not only easier like this. So, this one, the prime numbers. Somebody will say, oh, teacher, what is prime numbers? The prime numbers are whole numbers, has only 2 factors, like 1 and itself. So we call them prime numbers. Let me give you an example, like 7. 7 equals to 1 times 7, right? Can you find any other integers? And then you multiply that, it can be 7. I don't think so, right? So you need to remember these 2 factors. These factors should be the integers greater than 0. Yeah, greater than 0. Okay, so for 7, this number only has 1 and itself. 7 is the prime number. Like 5. 5 equals to 1 times 5, right? And there is no any other integers. You multiply them, you can find the product is 5. No. So 5 also has 1 and itself. So 5 is also the prime number. So how about 9? 9 equals to 1 times 9, right? But 1, can you find any other integers? Yeah, of course. 3 times 3. Okay, so for 9 have factor 1, factor 3, and factor 9. So for 9, actually this number includes 1, 3, and 9. In total, it has 3 factors. Besides 1 and itself, 9 also has the factor 3. Yeah, factor 3. So 9 is not the prime number. We call this number, we call 9 is composite number. Composite number. Composite number means contain at least 1 divisor other than the number 1 and itself, like 3. Yeah, like 3. Okay, so today your aim is to find the prime numbers from 1 to 100. Okay, and somebody will confused about 1. Somebody will say, 1 equals to 1 times 1. So you think 1 is the prime number? No. From the definition, we can see prime number are whole numbers have only 2 factors, right? 2 factors. But for 1 only have 1 factor itself. So 1 is not the prime number. Of course, 1 is not the composite number either. So 1 is very special, not the prime number, not the composite number. So in China, we call it the famous number. 明星数, the famous number. Very, very special in this word. Okay, so you cannot circle it. Okay, you cannot circle it. And the next one, 2. 2 is an even number. And 2 equals to 1 times 2, right? And I think 2 only has the factors 1 and itself. So 2 is the prime number. Circle it. So how about 3? 3 is also prime number. How about 4? 4 is an even number. So as long as I give you a number, oh, where is my pen? As long as it is a number, then you can find 1 times itself, right? So this number has 2 factors. So can you find any other number integers and multiply them? You can get the product is 4. Yeah, of course, 2 and 2, right? 2 and 2, because 4 is an even number. So as long as it is an even number, it must be the multiple of 2. Like 10 equals to 2 times something, right? Because 10 is the multiple of 2. So when you see the even number except 2, then this even number must be the composite number. Like 4, like 6, like 8, like 10, because they are all the multiple of 2. So besides 1 and itself, this number must have any other factors. Conclude 2 and another number, right? Okay, so you can drop this one, this, and this column, right? Just to drop them because they are all the even number. They must be the multiple of 2, so they are not prime numbers. Also this part. Ooh. Okay, drop them. And next, for 5 is prime number. 7, also prime number. For 9, okay, we know 9 is not the prime number. 9 is the multiple of 3, right? 9 is the multiple of 3. So, if I give you a number which is the multiple of 3, then it means besides 1 and itself, this number have the factor 3. So it must not the prime number. So we can drop it. Yeah, drop it. You can drop all the numbers which are multiple of 3. So let's find them. We know the characteristic of a number which is the multiple of 3. How can you tell them? Yeah, look at the sum of their digits. 看数字和. As long as the sum of digits can be divisible by 3, then this number must be the multiple of 3, like 15. 15, okay, so the sum of digit is 1 plus 5 is 6. So 6 is the multiple of 3, right? So this one, it must be the multiple of 3. Yeah. Another example like 81. So for 81, the sum of digit is 8 plus 1 is 9. 9 is the multiple of 3. So 81 is also the multiple of 3. Yeah, like 111. 111. The sum of digits is 1 plus 1 plus 1 is 3, right? 3 is, of course, the multiple of 3. So 111 is also the multiple of 3. So can you get this strategy? Very easy, right? So let's drop the multiple of 3 together. So 9 is, and then 12 is, but 12 is also the multiple of 2. You already dropped it, right? You don't need to drop it again. So 15, and then 18, and then 21, and then 24, and then 27, 30, and then 33, and then 36, and then 39. Okay, if you find the receipt or if you find the secret, you can see everything you dropped, every number you dropped, the difference is 2, right? So you can just count 2 grades and then drop it. Count 2 grades, drop it, drop it, drop it, drop it, and drop it. Yeah, just like this. Drop it one by one, and this one, and then this one, and then this one, and then this one, this one, and then this one, and then this one, and then this one. Again, 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 again. Okay, this work. This or the multiple of 3. Okay, and next one. We can use this way to drop or the multiple of 2, the numbers who are the multiple of 3, also the multiple of 4, 5, 6, 7, or blah, 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 right? So you can use this way. Exclusion method to drop all the composite numbers so you can get the prime numbers, right? It's so fast. If you tell them one by one, I think it's a little time consuming. So next one. Let's drop the numbers who are the multiple of 4. Do you think we need to drop it? Like 4, 8, 12, and 6. When you see this table, you can find that these numbers are already dropped. Why? As long as a number is the multiple of 4, it must be the multiple of 2, right? And this kind of numbers, you drop them already, so you don't need to drop again. Okay, next one. Let's find the multiple of 5. So the character of the numbers who are the multiple of 5 is the last digit should be 0 or 5, right? Like 10, 15, 20, right? This is the character. And you only need to drop this volume. Yeah, drop all of them because this volume is the multiple of 5. And the last volume, the last digit 0, you already drop it. You don't need to do it again. And the next one, drop the numbers who are the multiple of 6. Do you need to do that? No. As long as a number like 18 is the multiple of 6, it must be the multiple of 3 and the multiple of 2, right? You already dropped them, so you don't need to do it again. Next one, drop the numbers who are the multiple of 7. 7, 14, or 21, and then 28, and then 35, and then 6 times 7, is 42, and 7 times 7 is 49, right? And 8 times 7 you don't need to consider because 8 times 7 is the multiple of 2. And then 7 times 9, you also don't need to consider that because that number, 7 times 9, that number is the multiple of 3. You already drop it, right? So 8 times 7, you don't need to consider. 9 times 7, no. And then 10 times 7, no. This one is the multiple of 2 and 5. And 11 times 7 is 77, right? Find it, drop it. Okay, and then 12 times 7, no, because 12 is the multiple of 2. It means this number also is the multiple of 2. And then 13 times 7 is 39. Okay, drop it. And then 14 times 7, no, 15 times 7, already over 100, so you don't need to list it anymore. That's work. And then multiple of 8, we don't need to consider. Multiple of 9, we don't need to consider. Multiple of 10, we don't need to consider because this one is the multiple of 2 and 5. You already drop it. Okay, multiple of 11, no, you don't need to think again because you already drop it. Like 1, 2 times 11, 3 times 11, you already dropped them, right? So you don't need to consider anymore. That's all. And the rest part is the prime number. You only need to circle them Okay, circle them. During from 40 to 50, 3 prime numbers. From 50 to 60, 2 prime numbers. From 60 to 70, 2 prime numbers. From 70 to 80 to, three prime numbers. From 80 to 90, 2 prime numbers. From 90 to 1, I forgot this one. This one is the multiple of 11, also 9, also 3. Okay, drop it. Okay, so from 90 to 100, we have 2 factors, right? 2 prime numbers. Okay, that's all. If I organize them together, so here is these, okay, these prime numbers. Okay, when we observe them, you can find apart from 2, apart besides 2 or except 2, or the rest part is the odd numbers, right? The odd numbers. So 2 is a very, very special number. We can see except 2, all the prime numbers or the even numbers are the composite number, right? Only 2. This is the even number, also the prime numbers. So the 2 is very special. Also the common questions during the exam. So pay attention to this one. And the next one. When you see this, when you see these prime numbers, you can see the last digit is 1, 3, 9, and 7, except 2 and 5, right? You just drop 2 and 5, you can find these prime numbers. The last digit is or 1, 3, 7, 9, 9, 9, 1, 7, all of them. Okay, so if I give you a question that as long as the last digit is 9, then this number must be the prime number. Do you think it's correct? No. Okay, because 9 is not, right? 9 is not. 39 is also not the prime number. So this is also the features. You cannot give it a definition, okay? I just help you to remember the prime number, but you cannot say that, the last digit is 1, then it must be the prime number. No, definitely not, okay? So this is all the knowledge I want to show you in this lesson.